Okay, and the stream is up and going, and I think we are live. So, good evening, everybody. Good afternoon, good morning, good middle of the night, wherever it is that you are in the world. Kees and I are enjoying seeing all of the hellos coming in on the YouTube chat, showing us where you are. We've got a great selection of locations around the world. Plenty of places for me to put on the to visit list once we're allowed to leave the house. I tell you, as soon as the flights start coming out of the UK again, I'm gonna be somewhere. I don't know where yet, but I just need to get on a plane again, I think. So yes, good evening. Hello and welcome. Hopefully you guys have all enjoyed the homework from yesterday, with turning your photographs into sparse clouds and then dense clouds. It's really nice to see the results coming up on the Facebook group. Please do keep sending us results as and when you get stuff through. So let's have a little talk about what we're going to do today. Just going to use, I think, today. That's going to be easier than I think it's. I think it's the evening. It's quite late for me, but it's still early for Kees. So I think today is going to work as our descriptor. Yeah. So yeah, we're going to start with a little bit more advertising about GUE and tell you a little bit about the GUE fundamentals class. I won't go into this now because Kees is going to talk to us about that in a moment. We're going to have a look at some of the questions that we received from the homework, and we're going to talk through some of the things that you guys have found that you've asked on the Facebook, and we're going to cover some of that. And then we're going to talk about what do we do beyond the points. How do we go beyond the points? What's next? And this thing that we call meshing. So we'll talk through what meshing is, and then you're going to have some homework to do before next weekend for the final session. We ended up having to change the session next weekend, so it's on the Sunday, not the Saturday. I will try and make sure that the emails go out early and remind you of that. I'll try and set that up this evening so they go out in the middle of the week to remind you. Cool. So without further ado, I shall hand over to Kees, and he can do a bit of a spiel for us.
Sounds good. Thanks, John, and hello, everyone. It is fun to see everybody's good mornings or good afternoons or whatnot roll in from around the world. I know some people have nicer weather. I'm not sure if that's a blessing or a curse in the situation that we're in right now, though. So we wanted to take another opportunity today to start off with talking a little bit about GUE, and in particular, sort of our banner course, GUE Fundamentals, before we jump into the rest of photogrammetry. GUE Fundamentals is sort of our foundational class. It's our entry point for any diver who doesn't have GUE training. That's everyone from, the 30-year experienced technical diver who wants to polish up some skills, to somebody who's fresh out of open water training and, likes what GUE is about. So anybody that comes into GUE takes fundamentals. That way we can get everybody on the same page. Again, GUE, what we're about is making really solid teams and really solid divers above everything else. And having everybody have this foundational training is really useful, even if it only serves as an introduction to our specific way of doing procedures, so that when we go out and we do, say, a photogrammetry dive, everybody's on exactly the same page. You don't need to worry about anything being different. In fundamentals, like in all of our classes, we do our very best to repeat things through a series of drills, both on the surface and in the water. So, we practice things a couple of times on the surface, like we're doing now with photogrammetry. And then in the same way, we would take that underwater to practice there, give everybody an opportunity to mix things up a little bit, mess things up a little bit, and polish them off before the end of the class. GUE focuses on realistic training. So, there's arguments to be made for sort of water comfort challenges, like taking off your gear underwater and putting it back on. Realistically, I don't do dives where I have to do that. So that's not something that we focus on in training. And in the same way, like in fundamentals class, you'll find that most of our skills and drills are designed around practicing things in as close to real circumstances as possible. That means, again, that we're trying to do skills and drills that you're actually going to use, or ones that you'd need to use in an emergency, so that we have a lot of time to focus on the absolutely necessary stuff, and we can reduce some of the other items. Because it'd be great if we could teach a 2-week fundamentals class, but typically we teach it over about a 4-day period. That's because, of course, mostly economic concerns. Everybody's got a schedule, and I don't think anybody wants to pay one of us to come in and train you for 2.5 weeks. It'd be prohibitively expensive. But if you are interested in that, please do let us know.
Yeah, it would be lovely if we could do that. I'd be very
great.
happy to do that.
I say that at the beginning of every one of my fundamentals classes, and honestly, every class that I teach is basically, we could make this a 3-week class if we wanted to. We'd still have plenty of stuff to polish by the end, but it's not realistic, so we're going to be busy. So GUE Fundamentals is a prerequisite for all of our classes, apart from sort of our entry-level classes, and that includes photogrammetry. And that's specifically because we want to make sure that everybody's team skills and maneuvering skills are exactly where they need to be. So that in a class like photogrammetry, we focus on exclusively photogrammetry, and we don't have to worry quite so much about introducing maneuvering skills or so on. Fundamentals also forms a prerequisite for our cave, technical, and advanced recreational diving programs. If you have any interest in going into one of those environments or taking a class like GUE Photogrammetry, do get in touch with either me or John. Again, John is based out of the UK. I'm based out of the United States in Seattle. So we should have one of us on roughly your time zone. And both of us do travel. And if you've got a local instructor, we're happy to put you in touch with them as well. All right. So back to photogrammetry. Let's talk a little bit about what we've done so far and where we're building towards. So the first thing that we've done is built a sparse point cloud. This is a sparse point cloud of a model that we did here near Seattle, of a car that went off road in a local lake called Lake Crescent. It's quite a pretty road, but back in the day, it was quite dangerous. It was very windy. At the time, it was made out of dirt. It was on a sheer cliff, and they didn't have any guardrails. So somewhat unsurprisingly, there were some tragedies along that road, and this car actually is probably about 30 meters away from another car that went off exactly the same corner and at the same time. They call the corner ambulance point for not surprising reasons. Anyway, so this is our sparse point cloud. The sparse point cloud is really generated as a byproduct of figuring out where those photos were taken from. It's a byproduct of the alignment process, where each one of those points represents a contrast point on your object that Metashape was able to use in order to identify where the photos were taken from. At the sparse point cloud stage, you can get a good sense of whether or not your alignment worked pretty well, either by taking a look at your chunk and seeing how many photos aligned manually, but also just by looking at the sparse cloud itself. If you can tell what your object is, and it looks roughly like what it looked like in real life, there's a good chance that you got a good model. If there are blank spots or dark spots, that might mean that that area has low contrast. It's very smooth, it's very even surface. Or alternatively, it might mean that some of the photos in that area didn't align, which of course can be a byproduct of low contrast. It can also be simply that that area of the object is dark. So here we see pretty good coverage, and sort of towards the front near the hood of the car, you can see sort of an empty spot. That's an area of pretty low contrast on the rec, not an indicator that we've done anything wrong. So what you hopefully did last night, or what you'll do this week if you're catching up and viewing this ahead of time, is build from this point cloud, again, the byproduct of the alignment process, into the dense point cloud. If we could jump ahead. Now, the dense point cloud is obviously much easier to see. You can start to make out details, like the little memorial box at the front of this car. the headlight, the wheels, and so on. The dense cloud is really a tool that Metashape is going to be able to use in order to build the final product. The big difference between this and sort of a final complete 3D model is that this dense cloud model is still points. If we were to zoom in really, really close to this dense cloud, we would still see that it is a bunch of dots in space. Just real quick, just answering questions as they come in. Keith is asking, what do you do if you have a fish or a buddy that accidentally gets into your image or model? Well, what you'll see, and what you may have seen already if you had something move around, is that Metashape more or less ignores anything that moves. This is a disadvantage if we are moving things, because if we move things, then the thing that it ignores is everything, and you won't be able to get a model out of that. But if there is a fish or a diver that's moving around in your object, generally it'll be ignored, provided that it doesn't actually block the model itself, or that they aren't stable enough that it tries to render them in. I've done a lot of photogrammetry with folks using lights or folks around me. As long as they're moving, I find that it's not a big deal. Okay, so we built our dense cloud, and remember the dense cloud, like the sparse cloud, is still just a bunch of points in space. I like to think of it sort of like a connect the dots model, and like a connect the dots model, the very next thing that we're going to do is connect all those dots. That forms what's called the mesh. Now, the mesh has a notable difference from the point cloud models that we've seen so far, and that's that it doesn't have any color to it. You can get some very basic color if you tick the right box in the processing, but it's still going to be pretty low quality. At this point, though, if you zoom in, you'll find that the model is actually made out of faces or triangles. That means it's a solid or largely solid object, and we can take advantage of the fact that we have a bunch of photos of this to make it look even more realistic. So the advantage here is that this mesh is going to be sort of the standard 3D model that we can put into any number of other programs or display online quite easily. But of course, we do want to get that color back, and we have all that information because we've got those photos. So at this point, I think about the model a little bit like a model kit that you might make as a kid. When you put it together, it comes and it's all gray plastic. But it doesn't have any paint on it. It doesn't have any little stickers on it or anything to make it look at least a little bit more realistic. So our next step is going to be to take those photos that we've taken of this model and spray paint it. So today we're going to go to the mesh stage, and then our final product is going to look something like this, textured mesh. The textured mesh, again, is where we've taken all of the image data and used it to fill in the details on the mesh. And then all of a sudden, you can start to see a lot of objects that maybe weren't able to be rendered into the model itself. For example, right behind the headlight in the front of this car, you can see that there's a grill on the side. That grill is not actually rendered into the 3D model at all. It's too fine, but it does appear in the photos. And because we have a good texture here, we are able to actually see it in the final model. Similarly, inside the car, you might see some springs through the passenger side window, or I guess it's a passenger side window for some of us and a driver's side window for the rest. But you can see the springs from the seat in that car. And again, that only exists because we've been able to spray paint this with the image data from the photos. So this is going to be our final product that we'll generate in session 4. And then we'll also talk in session 4 about how to get this from inside of Metashape into external programs so it can be displayed in full 3D.
Kees's stream to me has just fallen over. I'll just give that a moment and hopefully it'll come back. Good. Okay. Well, I'll take over and fill for a bit whilst the internet gets its self-backing gear. So what Kees is saying there is basically to enable us to be able to output our model and share it with the world in real 3D so that they can then actually move around it and scroll around it. Yeah, pretty much Leon. Yes, he's vanished. Give me a second, and I'm sure we'll get him back momentarily. Okay, well, whilst I hope that the internet lets Kees come back. Oh, let me just turn off his window for a moment until I see him return to us. Let's start having a chat about some of the questions that we got through the homework. So one of the questions that we saw coming in was, oh no, I've got an error message that is basically saying that I haven't aligned, that all of my photos have not aligned. The common reason for this is normally that you have not got quite enough overlap between the images. So either you haven't taken enough photos, or that you've got too close to the object. If you're too close and something sticks up, then it will fail on an overlap. It could be poor lighting conditions, so it could be too dark, it could be too bright. If your object is shiny or reflective, this can cause you some fairly major problems. Or if the object is too smooth and doesn't have corners or high contrast points, then this will make life harder for you. We've seen a couple of things in the homework already for that kind of problem. Maybe if you've done it with video, why didn't it work? It could well be that you've moved too fast and so you've just got blurry images. Or it could be poor video quality. So again, if you're moving quite quickly, the compression on the video tends to get ramped up, and then you get more compression going on in the imagery, and you will get less good data for Agisoft to be able to align. So if you remember what Agisoft is doing, is it's looking for points in every single image, and then it's going to try and compare the points in image 1 with the points in image 2. Compare the points in image 1 with the image 3, and so on. So if those images are a bit blurry, then it's not going to get nice, sharp, defined points that it can then use to set the position of the camera or set the position of the 3D objects that you're trying to model. So what can we do? Well, we can try again. You can always try taking more photos or taking photos from different angles. You can try picking a different object that has more texture or less reflective. We've said before, things that are good are kind of organic things, so rocks, a leather boot, a stump, a sofa. Anything with text on is pretty good because the text can come out as texture that it will find. Bad choices are reflective things, so cooking pans, scuba cylinders, cars, and that kind of thing. Let's pick up on this. Rob has asked, do photos need to be sequential, or can you go back and redo areas you feel need more attention? They don't need to be sequential, but it is often better if they are sequential. If you're just doing the homework type practice here, where you're looking at 50, 60 photos, it's probably better to just start from scratch and take a new data set. There are procedures where you can go back in and pull more images into a data set and process, but it's trickier. It's not hard. It's just trickier to do. It takes more stuff to do. Will Metashape mark or identify the images that cannot be used? Yes, basically Metashape will tell you which photos have and haven't been aligned. I'm actually going to move on in a moment just to show you some of the stuff around Metashape anyway, because we've had a few questions about this. So let me bring up Metashape. I pulled up another model to play with to show you guys rather than my motor scooter that was a bit too shiny. So here I've got a dense cloud of a model. Aha. And Kees is back in the house. Let me turn him back on. Hello, Kees.
A brief little power outage there, so that was fun.
Awesome.
Dramatic.
Yeah, there we go. Okay, right. Well, so Rob has just asked, will Metashape mark or identify the images that can't be used so that we can review them and learn what was wrong? So this is basically what I am showing. So if we see here, I've got my model in the middle and my photos down the bottom here. And hopefully you can see this little grey tick next to the photos. This grey tick tells me if a photo is aligned. Another way of looking at this is if I open up my chunk, so I do the little drop down, and I see my cameras list here. If I open up the cameras, actually no, sorry, I have to pull it up in the reference pane. I thought this, no, this should, oh no, that's right. This, if I have a camera that's not aligned, it will say NA next to it. That's right, sorry. So if I, here we go, let me forcibly unalign a camera. There we go. We can see that it gives me an NA next to that camera if it hasn't aligned. So you can then scroll down here, and any that say NA will be not aligned. The other thing that you can also do is down here you can have a look and you can filter by alignment or non-aligned. That's quite useful sometimes to get an idea of what has and hasn't aligned. And let me just put that one back into the bottom. Okay. So a couple of other
Casey, can I add something real quick there?
Absolutely.
If you don't have any of those, they call them panes, like those little like windows inside. You can get them by going to View and then opening them up. The pane that has the chunks in them is called the Workspace pane, and the pane at the bottom with all the photos is unsurprisingly called the Photos pane.
Yeah. Okay, cool. So let's have a look at navigating around Agisoft a bit. Obviously, up in the top left corner, you see your normal icons, Windows icons, Save, Open, and New. We then move into the kind of model manipulation tools. So we have we have the pointer, we have a selection tool, we have the photos tool, the region tool, and then there's some other tools up here. Then we get into the view tools. So you have zoom in and out buttons. We have a center button. So if you click that, it will centerize it to the 0 on the XY plane and looking down through the Z plane, for anyone who cares about that. We then get 4 dots. So 4 dots is my sparse cloud, the point cloud as we call it. I then have the 9 dot icon. The 9 dot icon is my dense cloud. And again, that you get some options underneath there that you can look at. Then the next thing we get to is the model, and when we drop down here we have model shaded. So this would be my mesh. This in this case this is the colored mesh. I can do model solid, which just takes away those colors and it just shows me the solid faces. And I have model wireframe. So this is where we see those triangles that Kees was talking about in the model. The final option really under here is this model textured, which is what we'll get when we've completely finished the model, which we'll talk about next session.
And we've got a quick question from Danielle here. How does Metashape, or what does Metashape use to determine the X, Y, and Z axis? It can't determine that, so it's largely going to be random. Yeah. There's no way for it to arbitrarily determine what is up. So you can, we're not going to cover this in this class, but there is a way that you can manually redefine the axes so that you can do some sort of advanced processing. But yeah, for now it's basically random. Got another question from Robert. My model icon is grayed out. How so? The reason that your model icon is grayed out is probably because you have not generated a model yet. So the model is the mesh, and that's what we're going to be covering today. Yeah. Is how to mesh your dense cloud.
Yep. So if you've only got the dense cloud, then this model icon will be always grayed out. So one of the things I'm going to do just before we talk about how to make the mesh is you may well see in space there's kind of floating bits. And these might be quite close to your model, they might be further away, and this is certainly for any of you who try to do this underwater, you'll get a lot of this stuff because Agisoft will try to model the background, and it will struggle. And this sometimes turns up as kind of floating things. So I want to show you this tool up here, this selection tool. Currently it's a rectangle. I quite like the freeform selection tool. So in my dense cloud, if I have noisy things like this, I can basically just click over the top of them and they go pink, and then I hit the delete button, or I think it's edit delete selection for those of you on Macs, because I haven't managed to find out what the mouse command is for that on a Mac. And you can go around your model, and anything that's not supposed to be there, you can remove and delete. So we can kind of delete bits that don't need to be there by simply selecting them and then deleting. We had a couple.
John?
Oh, gone. Yeah.
Oh, what if I saw something that was right in front of the gnome's face and
Yes.
I wanted to select that? Would that have any byproduct effects?
Yes,
Side
indeed.
effects?
Yeah. So let's pretend I had an object that was just floating on the front of the hat here. Let's pretend this U here is what I want to get rid of. Now, I could try and select that and delete it, but the problem is that this deletion tool is like a bullet. It fires all the way through the object. So if I turn Gnome around here, you can see that the back of his hat is also selected. So you need to be kind of careful when you're doing this. You need to try and make sure that there's nothing in the background behind your object that you don't want to get rid of. It is a very coarse tool, and it will shoot holes straight through the middle of your object.
Also of note here, if you do get an edit undo history like you would in most software. So if you make a mistake, you shoot a hole in your model. That's we have all done it. You can go to edit undo, but if you're in the habit like me of saving very, very frequently, it is also important to note that saving in Metashape will delete your edit undo history. So it is entirely possible to accidentally shoot a hole in your model, hit save so that you save your work, and then lose the ability to undo it. So it is very important when you're deleting data to be sure and rotate around and make sure that you are deleting precisely what you want to delete and nothing more. Because it's, you can make mistakes, and it can sometimes be hard to recover that data without reprocessing.
Yeah. Cool. So a couple of other things that people are asking about. How do we get rid of the trackball in the middle? So basically model and show hide items. Personally, I would suggest that whilst you're learning how to use Metashape, you leave the trackball in place, because basically with the trackball in place, you can grab it in one axis and move your object around and rotate it just in that one axis. I tend to leave mine turned off because I've now done thousands and thousands of hours using this thing and kind of know exactly where to click in the screen to pick up the axis anyway. I think Kees probably does much the same as I do and leaves it turned off. But so if you want to see or not see stuff, you can go to Model, and then you have this show and hide menu. I think we also have in here, so you can also turn the cameras on and off in that menu, so you can see where your photos were, which you can also do from up the top here on the camera icon. Just saw a question in from Paul. Can you delete artifacts at any stage of processing? Yes, you can. It will only delete. It will only affect anything that is then processed after that point, though. So if you have deleted something in the dense cloud and you go back to the sparse cloud, it would still be there. Or if you delete something in the mesh and go back to the dense cloud, it will still be there in the dense cloud. So it doesn't let's say delete backwards in time. But if you then did processing going forwards, that thing would not be processed. Anything that you've deleted will not get further processing.
I'd also add that I'd recommend to delete stuff at least in one of the cloud phases, either the sparse cloud or the dense cloud. If you have an artifact that's very close to the surface of your object, and you mesh that and then try to delete it later, what you'll find is that you can have a hole in your model, and it's much harder to correct that after you have the mesh. Whereas if you delete it in the point cloud phase, it will take that into consideration when it is meshing and sort of automatically patch that hole. So again, I recommend doing that either in the sparse cloud stage or the dense cloud stage if you're going to do cleanup. You can do it up later, or do it later though if you need to.
Okay, Earmat has come back and said for delete on a Mac, this is custom hotkeys. So I think that would be in. I'm not actually sure where you get shortcuts. Here we go. Yeah, so you can set up custom shortcuts in the preferences menu. So for those of you on Mac, that's under the Metashape menu and then preferences. Okay, another thing that somebody mentioned on the group was they were getting the error saying not all of my photos have aligned, and so my response to that was how many have aligned. The easiest way to find that out is when you look at your chunk. It says chunk 1 here with 62 cameras, which means I had 62 photos. I do the click on the little arrow, and I then get my cameras list, and I see 62 out of 62 have aligned. So that's ideal. You want all of them to align. Generally speaking, underwater, if I get a 90% alignment, then I'm pretty happy most of the time. Again, with what you'll often find is if you've taken the photos properly, you'll get pretty good alignment. You might still get 1 or 2 that don't align, but you should get pretty good alignment. The biggest reason that stuff doesn't align is that it's just there's not enough overlap really. Myra, so for deleting on Mac indent cloud not working for me. Okay, I'm not sure we can easily cover that because I don't quite know what is and isn't working, but feel free to come onto the Facebook group later and we can go into that in more detail and try and find out what the problem there is. Certainly the delete key will not work on the Mac. You have to go edit and then delete selection once you've selected the thing that you want to delete. Okay, let's return to the spreadsheet. No, not spreadsheet, the PowerPoint. Here we go. Okay, so we have our dent cloud. We can use the selection tool and delete to help us clean up our model a bit. And then the next step is this thing called building the mesh. This is where we are going to take our model made out of lots of dots, and then we will add those surfaces, make it solid. As with align photos and as with build dent cloud, we have a whole bunch of options here. Now it's really important to notice this first one, source data. There are 2 options for source data. Option number 1 is depth maps, and option number 2 is dense cloud. So what I would suggest is, for the time being, for the first time round, is use this where it says dense cloud. So that's going to use the dense cloud that you have created, and then make the solid model based on that dense cloud. We're going to talk about what depth maps means in a minute anyway. Okay. Quality, just like for dense cloud and sparse cloud, this is a tie-in, a balance between processing time and accuracy, let's say, the quality of the thing. So for the homework, I would stick with medium. Generally, we stick with medium unless we have a good reason to move to something else. The face count, again, you can set this, I think, low, medium, or high. There's also a custom option. I would just leave this for medium for the time being. These are pretty good places to be. It gives you a good understanding of whether or not your mesh is going to work or not. Okay, under advanced, we have this thing, interpolation. Unless you have a good reason not to, just leave this as enabled. This is all to do with what Agisoft is going to do when it finds a hole in the model. How it manages, let's say, a hole in the model or an area with poor data. So again, I would always leave this enabled unless I was finding a problem, and then I would change it. If you are building the mesh from a dense cloud rather than a depth map, you might get depth filtering. I would generally leave that on whatever the default is, which I think is probably aggressive. And finally, here on the calculate vertex colors, I would leave that ticked. So that means that you get both. If you tick it, it means you can get this colored texture model. So it is not the photographic texture, but it is at least colored, which gives you an idea of what the thing is going to look like. If you unclick it, you will only get the grey model. Okay, so when we look at that for real, we get this, as I said, with dense cloud. Oh, yeah, so one last thing. When you do it with a dense cloud, you get this option, surface type. And there's two options here, arbitrary brackets 3D or height field 2.5D. Unless you are trying to 3D map a field where you really don't care too much about the detail, then just leave that as arbitrary. The height field effectively means that for every XY coordinate, there is only one Z coordinate. So it makes a single surface that kind of has no tuck unders, no real 3D depth. It's just the average height at that point. So if I did that on this gnome model, I'd probably get the hat okay, but then it would kind of just come down almost like a Christmas tree all the way to the floor. With the arbitrary 3D, it means that we can have multiple Z values for each XY value, and therefore we can get the proper model going on. So leave that alone. Cool. Anything you want to add on there, Kees?
Yeah, no, that's absolutely right. The surface type, basically everything that we're ever going to do is arbitrary. 2.5D works great for what Metashape is arguably designed to do, which is like drone photogrammetry of like farms or fields or cities with buildings. There aren't a lot of buildings, at least where I am, that have overhangs, but for our purposes, it's basically useless.
Yeah. Okay. Leaving the face count kind of high, that's good. It will give us more detail and more depth, more kind of resolution, let's say. We can always reduce that later through a thing called decimation, which is a tool that we will actually be using in session 4 anyway, probably before we try to export to an online platform. Okay, so this is kind of the main thing that we want you to do, is we want you to build a mesh based on your dense cloud, and see what you get. And up until about 6 months ago, that was all we would ever say about meshing, because this was the only way of doing it. You had to build the dense cloud and then build this mesh. About 6 months ago, Agisoft released a new version with an interesting new feature in it that we call direct to mesh. And this is where we can use the depth maps as the source data. And a depth map is an interesting thing. So let me again pull up a photo. No, I think I have to do it up here. Remind me where this is, Kees. Can you remember? As I said, this is very new. Here we go. Show depth maps. This is an old project. These might not have depth maps in them. Let's go to that.
Your moped. Yeah.
Yeah. So this should have. Here we go. So, and turn off the points. Okay. So you see this multicolored image. This multicolored image is basically anything that's kind of yellow is close to the camera. The red is further away. The green is a bit further. Actually, I think it's red to yellow to green to blue to dark blue to black. So anything on this that's black, it doesn't really have good depth. So it hasn't really been able to measure how far away that bit of the object is. But it will generate these, and it can then make the mesh based on these depth maps. So rather than having to go through the process of the dense cloud, we can do the mesh direct from these depth maps, and it speeds up the processing. So why do we bother telling you about this? Well, why do we bother doing the dense cloud thing? So for some models, we get better results by going through dense cloud. For some models, we get better results by going direct to mesh. So they're both good tools to have to look at as a way of building your mesh. Let me pull up the PowerPoint again. Okay.
Yeah, what I like to think about these two. The direct to mesh will generally give you a better result automatically, at least in my experience. But it doesn't give you any control over what comes out. So if you go direct to mesh and the result isn't what you like, basically you don't have any ability to go back and manually influence the process. If you go through the dense cloud, through that process of cleaning that John showed you, and by using that tool carefully, you can decide much more manually what ends up in your final model. So, if you're just trying to get something working quickly, the direct to mesh is sort of my go-to these days. But if I don't like the result of that, knowing that I can go back and do manual cleanup of a dense cloud, that gives me a tool that I can use to create a model that I might not otherwise have the option to create.
Yeah. So another nice thing, and this is something I'll tell you about now, with the chunks. So what I've got here, for example, is I have my mesh based on a dense cloud in chunk 1. I then duplicated this chunk. So right-clicked on the chunk and clicked on duplicate. And so down here, I have a chunk where the model was made from the depth maps rather than from the dense cloud, so that I could actually then do a direct comparison between them, and there really wasn't much difference in this particular model. So let's close that down again. So as Kees says, don't be afraid to experiment. That's kind of the whole point of why we do these little sessions, why we break it up like this, and the big reason why we say aim for 60 to 70 photos maximum, because it's not too fast to run an experiment and run it 2 or 3 times to see how different settings affect your output. And yeah, do save stuff, but again, remember you can always save it as a new file name as well before, so that you're not destroying what you've done before. So this is meshing, and this is basically what the core of this week's homework is going to be. So what we would like you to be doing is take the dense clouds that you made yesterday, and then build meshes. So try building the mesh from the dense cloud, try building mesh from the depth maps. And do again, feel free to carry on experimenting. Try, take photos of other objects and see what does and doesn't work for you. It's always going to be interesting, and this is the whole point of playtime. Let's say is working out what does and doesn't work and trying to build a good workflow for yourself. Obviously, please do carry on sending us images in the Facebook group and showing us how you get on, and send us questions if you have questions. I've had a couple of questions about what's the best way to export the stuff so that we can see what's going on. At this point in time, the best way of doing stuff is to take screenshots or photos of the screen and send them to us. We will next week be explaining how to output an entire 3D model so that people can view and manipulate that 3D model. But for the time being, let's not go too far ahead with that, and let's just stick with getting some nice meshes, hopefully. So kind of, we got Himad. Can you get the same quality of mesh the same as it looks on the dense cloud. That depends on your face count. It kind of often the dense cloud will look more detailed, but what you'll have in that dense cloud is a lot more poor quality data. So when you build the mesh tends to only use the better data that it's got. It needs good 3D data to be able to build those surfaces. So you do sometimes get stuff on the dense cloud that doesn't make it into the mesh because the quality of those points is not high enough for it to make it into the mesh. The other thing is that, generally speaking, and let me pull up the model again. So here in my chunk 1, my dense cloud has 50 million points. So to get a mesh that's the same detail as the 50 million points, it would need to have 50 million faces, and that would be a very unwieldy bit of data for the software to try and manipulate. As it is, I've got it here at 3.9 million faces, and it's okay. I actually do have a version of this that I ran on higher quality, and it ended up at 35 million faces, and that was actually very hard to work with.
Yeah, you'll end up, even on a really powerful computer, you'll end up needing to make decisions about quality versus ease of working with something. So you can go wild with this, but even on a high-end computer, it can be difficult at that point to just manipulate the model. I would say once you get all the way through to a good quality textured model, it'll look at least as good as the dense cloud. The mesh that just has the basic coloration on it, that generally will look a little bit worse than the dense cloud. So you take a little bit of a hit when you go to the mesh, and then in session 4, when we cover texturing, you'll recover a lot of that detail. Although, again, as John said, you may need to make some concessions for performance there.
And in the latest version of Agisoft, under the dense cloud, you can do the drop down here and get dense cloud confidence. And you see it kind of does this odd coloring. Basically, blue it's very happy with, red it's not very happy with. So you can see here the bits that it does and doesn't like, and it will try and it will definitely work on the blue areas. It will try as much of the green as it can, and if the red, and it kind of struggles with making a mesh around red areas because it doesn't really have the 3D data it needs.
And Emad, to answer your question, you can export a dense cloud. It's not, you're not going to have as many options to work with it. It's pretty much just the dense cloud. Whereas a meshed model, you can apply lighting to and so on. But yeah, that's totally doable. That's not something that we'll cover in class. But after the sessions are over, if you get in touch, I'll point that out for you. No problem.
The other thing is you can't add the photo texture to a dense cloud. You need the surfaces to get the photo texture.
The dense cloud is just the dense cloud.
Yeah.
It's just done at that point.
Cool. So we've covered a bunch of stuff today. That was what we were going with today. We've covered a bunch of stuff today. We've spoken about GUI fundamentals. And as I said, fundamentals or as Kees said, fundamentals is a prerequisite for the GUI photogrammetry class. The GUI photogrammetry class is a 4-day class that basically goes into a lot more detail on all of this stuff, and then takes you underwater and helps you learn how to work as a team to capture the data that you need to make models underwater. We looked at some of the common homework questions, and then we looked at building the mesh. And remember, this week the homework from session 3 is to create those meshes and have a play with those.
Also, important to note, keep in mind that this is the second time that we're running these sessions, and we appreciate some people have rejoined us from the first go round. So in the Facebook group, you'll see people jumping ahead. Not to worry. There are a lot of folks that have different levels of experience. So The goal at the end of this is not to get anything published. At the end of this session is not to get anything published, just to get to the mesh, and then we'll cover the remainder in session 4. If you want to jump ahead and you've got the knowledge necessary to do that, feel free, but don't feel obligated to, or don't feel like you've missed something.
Yeah, absolutely. So, and we get to my favourite bit of the entire class, the blatant plug slide. So again, we've spoken a lot about GUE and GUE classes and photogrammetry, so you know about that now. Please do follow us on the various social media platforms. And if you are enjoying it, please do consider dropping a small tip into the online tips jar. It helps keep us in quarantine beer. Which is definitely deeply appreciated. And again, as always, we like to mention this, the Mars Project. The Mars Project is the ongoing project to document a 450-year-old shipwreck in Sweden in 75 meters or 250 feet of water. It is one of the most advanced and adventurous 3D photogrammetry projects ever attempted underwater. We're working on trying to get sub-millimeter accuracy over the entire wreck and the surrounding areas, which is a significant challenge. So please do go and visit the project and follow that, because it's kind of cool. Kees,
Also,
question. Go on, Kees.
Oh, did you how many GUE photogrammetry classes have you guys taught so far? Any planned classes for 2020? I've taught one so far this year. I had one that was canceled, unfortunately. I think I speak for both John and I that provided that some of these restrictions are lifted and that it's safe to do so, that we will be teaching more classes in 2020. I'll be teaching them here in United States West Coast area, and John in that sort of
everywhere
drive on the wrong side of the road area.
Yeah. In terms of classes, the class has officially existed coming up to 2 years. It'll be 2 years this summer since we officially launched it. But we were running beta classes for about 2 or 3 years before that. So we've actually been running the class almost 4 years probably now. And I think there's been about 15 or 16 classes taught, maybe a bit higher now, across the board. It is actually a really fun class. I don't know anybody who's taken the class who hasn't come out having had a lot of fun during the class.
Yeah, mine too, Annika.
Definitely hoping for a good year.
fingers crossed. I mean, the cool thing about the photogrammetry class, and this is something, this is the reason that we developed it, was basically out of a need. We both, John and I, have been involved in the Mars Project and other projects where photogrammetry is a huge part of it. The big advantage with photogrammetry is that you get a lot of data that you can't otherwise get, right? We find that on the Mars Project in particular, when we're working with scientists, and I've found when working with scientists on other projects, that the things that they find interesting are not necessarily the things that I would think are interesting. At the same time, my ability to get to shipwrecks is much, much greater than most of the archaeologists out there in the world. What photogrammetry allows me to do is take photos or video that it's good documentation on its own, right? But it can then be, if it's done properly, it can be stitched into a 3D model like what we're doing here. And when that happens, we can go back, and the archaeologists or the scientists can look at whatever it is they find interesting, even if it wasn't the thing that caught my eye, because it very rarely is.
Yeah. Another really kind of cool thing that we found with Mars is we try to make sure that we always have at least one scale ruler into any small model that we're making. If we're making a model of an artifact or something that we found, we make sure that we've dropped at least one scale ruler into the area, and then it's actually one of the functions on the professional version of the software, is that we can then immediately scale the model, so that we can then, as soon as we process the model, we can scale it, and then the science team, the archaeologists, maybe will ask us, how long is that thing? This is particularly important for things like bones. If we find any bones on the ship, we want to try and work out fairly rapidly whether they were human remains or animal remains. and so we can then make simple measurements based on the scales that we've got, and it's much quicker than having to show them it on a video. They go, that's really interesting. Then we have to go back down on the next dive, try and find that thing again, and then start measuring it. So we're wasting dive time on going back to the same things.
No, it's profoundly useful, and the photogrammetry class is designed to get divers to the point where they have sort of a basic understanding of underwater photogrammetry, because it's challenging, like you've seen here on the surface. It gets doubly challenging when you have to control your buoyancy and your trim and lighting and so on. But really, we devised that class because we want to have people able to do this on projects, because it's such a useful tool. It's so useful. I have not been involved in a project where photogrammetry was not a part of it. And I went to, I was lucky enough to go to Society of Historical Archaeology, their underwater shipwreck conference earlier this year, and go around and see projects that were coming out of academia, not just the sort of diving side of things. And it's like every single one of their projects involves photogrammetry. So if you want to make yourself useful, that's a really easy way to do, and that's what the class is designed to do.
Yeah. Cool. We got a question here from Keith. How has the GUE partnership with PowerLens been? How does your PowerLens setup look like? So yeah, PowerLens are a really cool company, a really cool bunch of people. They are very passionate about the diving side of things. They're very passionate about conservation and trying to build ocean conservation into things. And they've been very generous with loaning us equipment and things. I've had, I think, 3 PowerLens cameras for the last 18 months, 2 years or something like that. So they've pretty much been on every project with me. A lot of the time, when I'm scanning, I have my big Canon SLR in a housing, and then I have at least one PowerLens strapped onto the top of it. So a lot of the time, the PowerLens is my backup camera. So I'm running it all the time anyway, but I don't often end up using the data directly from the PowerLens unless something has happened with the Canon, because taking high-resolution stills with an SLR is always going to be better than taking video. However, certainly I've done a load of cave mapping stuff and cave photogrammetry stuff with an array of power lenses. So I can't really show you what my power lens setup looks like, because it changes based on the project the project that we're involved in. I will try and find the photo of the cave mapper that I put together for a Sardinia project last year and throw that into the Facebook group. It looks a little bit like the first nuclear bomb that was held together with duct tape and zip ties. But yeah, it mostly worked, so that's cool.
Probably just about as safe too.
Yeah, slightly cheaper, I think. Not by much, but slightly. Cool. Okay, so obviously, if anyone has any more questions, we'll give it another 30 seconds or so for you guys to type them in. But otherwise, thank you very much for coming today and listening to us again. I hope you guys are having fun with this, because that's kind of part of the point, is get out there and have some fun whilst we are unable to go diving. Yeah. Yeah, so if there isn't anything else at the moment, we will sign off. But obviously, if you do have further questions, then do drop them into the Facebook group, and we will do our best to answer them as they come in. So from me, thank you very much.
Yeah, and thank you very much for joining us, everybody. Good afternoon, good evening, good night, good morning, and so on.